So we'll do the second part of this. Second part is on page 158. Slopes of the parametrized curve. So if you have a function that is in a parametric mode, if it's in a parametric mode, we can say that dy dx is dy dt over dx dt. Okay, pretty simple. Okay, so you take, since x and y are both going to be in t's, you just take the derivative with respect to t and then divide them out. Okay, and that is on the top of page 158. Okay, so let's go ahead and see if we can use this and do example number 6. Example number 6, we have x is equal to secant t, y is equal to tan t, and t is between negative pi over 2 to pi over 2. So and I want to find what dy dx is. So dy dx is dy dt over dx dt. So dy dt is a derivative of this guy with respect to t. So it's going to be secant squared t. Then I want the derivative of this guy with respect to t. So that's secant t tan t. So secant t tan t. So as you see, the secant t and one of them cancel out. So I have secant t over tan t. Secant is 1 over cosine t. Tangent is sine t over cosine t. Multiply top and bottom by cosine t. These guys cancel out. I am left with 1 over sine t, which is basically cosecant t. And the question is, find the slope, no, never mind, is find the tangent line at the point is going to be root 2 and 1. So when, and where t is equal to pi over 4, so I'm going to put t is equal to pi over 4 here. So if I put pi over 4 here, this is going to be equal to 1 over sine t, sine pi over 4 is 1 over root 2. So basically root 2. So the slope is root 2. The point is this guy. So I'm going to go y minus 1 root 2, x minus root 2. And that is your answer. Okay. So that was that. Let's see, okay, we're good with that. Now let's go ahead and look at the power chain rule. And power chain rule is nothing that's really, I don't even know why they call it the power chain rule, because it's basically the same thing, but it's in a power function. So the function that looks like a power function. So let's see, let's just go ahead and do example number 7, see how it works. Example number 7. A, find the slope of the tangent of the line tangent to the curve that at the point where, okay, so I have y is equal to sine to the 5th x. X is equal to pi over 3, and I want to know the slope of the tangent line. Okay, so I'm going to have to find y prime. So this is basically what? This is the same as sine x to the 5th, right? So it's in a power, looks like a power something, right? So this to the 5th, so it's going to be 5 sine x to the 4th. Then I have to take the derivative of sine x, which is going to be cosine x. Right? And you want the slope, so I'm going to put that in here. Cosine pi, so I'm going to get sine pi over 3. Sine pi over 3 is root 3 over 2 to the 4th. Cosine pi over 3 is 1/2. So basically 5 5, 2 to the 5th, because I have 2 to the 4th. I have another one here, so I can combine that 2 to the 5th. And then I have root 3 to the 4th, so that is what? 3 times 3, which is 9. So it's going to be 9 times 5, which is 45 over 32. Right? Okay, that's good. That's the answer. Okay. And they just call this the power chain rule. Again, because this looks like something to a power of something else, right? Okay, let's do B. Now realize before we go on that this is different, totally different than if I had y is equal to sine x to the 5th, right? Now it's not sine x to the 5th, it's the sine of x to the 5th. So if I did y prime here, I'm going to go ahead and take the derivative of sine, so it's going to be cosine x to the 5th, and then I have to do the chain rule to this, so it's going to be 5x to the 4th. So you're going to end up with 5x to the 4th cosine x to the 5th, which is totally different from what we had before. Okay, all right. So that was just a quick reminder, okay, that you have to pay attention to what's actually going on there. Okay, let's do B. B, show that the slope of every tangent, a line tangent to the curve, that is positive. Okay, so I have y is equal to 1 over 1 minus 2x to the 3rd. I'm going to take the derivative of this. So the derivative is, okay, so this is basically what? 1 minus 2x to the negative 3rd, right? So I take the derivative, I get negative 3, 1 minus 2 over x to the 4th. Okay, then I have to take the derivative of the inside, which is going to be negative 2. So I basically get 6, 1 minus 2x to the 4th. As we can see, the top is positive, the bottom is always positive because it's to the 4th. Okay, so you have positive divided by a positive. So this guy is always positive, always greater than 0. Okay, it's always greater than 0. And that's what they're talking about, where it means that it's always positive, right? So since y prime is always positive, the tangent lines are always going to be positive. Okay. Example number 9, it is important to remember the formula for derivatives of both and there. The assumption that x is measured in radians, not degrees. Okay, always your calculator should be in radians, right? So it should be in radians, because if it's not, then you're going to end up with something stupid. And that's all that's saying in there. And I'm not going to go over that one. Okay. Oh, that's it. All right, we're done. Okay. I have